Welcome back. In this section, we will discuss the details of the threading class, which is the main class we have to consider when developing multi-threading application in Python. Well, let's start by saying that here we will provide you an overview of the threading class. We will provide you all the knowledge you need to actually use threading class and to implement multi-threading application in Python. However, I strongly recommend you to refer to the official Python documentation to get more details on every aspect of the Python language, including the threading class. It's very important. That's the difference between amateur and professional developer. Okay, we have already seen this slide. Here we find the constructor of the thread class. As we said, the thread class can have several input arguments. Group is reserved for future implementation, and the value of group attribute should be none or should be omitted. Then we have the target. The target can be a function that you want to pass in order to implement the thread logic. We have already seen how it works in previous examples. Then you can specify a name for a thread. If you don't specify anything, a default name is assigned to your thread, and the name is in the format thread-n, where n is a number. So the first thread you create is thread 0, then you have thread 1, 2, 3, 4, and so forth, so on. Then you have args. Args is a tuple of argument that can be passed to the target function. So it's the argument that you can pass to the logic that actually implement your thread, in the case you pass in a function. Finally, you can have a KW-args, which is a dictionary of keywords that can be used to pass argument to the target. A really important method of the thread class is start. The start method we have seen in previous example. Well, the thread method is used to start thread's activity. It must be called at most once per thread object, and basically the start method calls run, and this creates a separate thread of control. In the case you call start on a specific thread a multiplicity of time, 2, 3, 4 times, well, this raises a runtime error because start can be invoked at most once per thread. Another very important method of the thread class is run. Run represents the thread activity, the business logic implemented by the thread. In the case you implement a new thread by subclassing the thread class, you have to override the run method in order to implement the logic of the thread. The method can also invoke a callable object passed to the constructor as the target argument. So basically, if you don't override the run method tries to call the target function that you pass in. That's how it works. That's the way you implement thread by adopting different approaches. Again, we strongly recommend you, whenever possible, to adopt the approach thread creation that follows the object orientation. So basically, the idea is you subclass the thread class in order to create a new thread. This comes with several advantages in terms of software engineering. Of course, in the case you pass in a function, we will use a list of args to actually pass in the function parameter. So in the case you don't subclass the thread class to implement a new thread and you want to pass in a function, you have also probably to pass in some argument. And that's why in the thread constructor, you have the args argument. So let's move on. In this slide, you see an example of creation of a new thread by passing in a function. As you can see, when you want to create a thread, you pass in as a target the myThread function to the thread class. Plus, you also pass some argument to the myThread function at its creation. So basically, you can specify these arguments in terms of a tuple. The first item in the tuple will be passing as the first class parameter, class argument, whereas the second tuple item will be the second argument of the function. So in our example, we will create a new thread by passing in the myThread function, and we will pass in hello there as message to myThread and one as delay to the myThread function. So this is how things work. Clear enough, it's more complex to build a clean code that takes care of setting thread, managing its state, etc. by using a function. A little note, here we slightly modified the previous code, and as you can see, we pass in a list of parameters to the myThread class instead of a tuple. Does it change anything? No, it's basically the same. So you can either specify a list of parameters to pass to the function, or you can specify a tuple. It's actually the same. Another important method we have discussed so far is join. Join blocks the calling thread until a thread with join method is called terminates. It can terminate its execution normally, namely, basically it completes its execution, the execution of its business logic. Or there's an unhandled exception, and in this case, the thread terminates. If you don't specify any parameter to the join, well, the method behaves like blocking primitives. So you wait the thread forever, basically forever. Or you can specify a timeout, meaning that you wait the thread for a finite amount of time. Let me say that in principle, several times you use blocking primitives, and this happens in most trivial example. But when you have more complex logic, you tend to use timeouts. You tend to use timeouts because you don't want to have a thread stuck waiting forever. And this happen more often than not. In this case, what happens? Well, if the thread you're waiting for does not complete its execution within a reasonable amount of time, probably there's something wrong, and you want to be there with your software waiting forever for something that is not going to happen. So you probably raise an exception. This is what happens. It's not a rule. It depends on, let me say, what you are doing, what your software is expected to do, etc. But this is not an uncommon way to organize your software. Well, in this vein, let me add that a thread can be joined many times, several times. So it's not uncommon. You wait for 3 seconds for a thread, then probably, I don't know, you update something, then you wait again for the thread with another join. It's correct. It's not a problem. It's possible. And let me add a final remark. Join raises a runtime exception if an attempt is made to join the current thread, as this would cause a deadlock. So if a thread tries to join for itself, this causes a situation where I'm blocked and I'm waiting for myself to terminate, and this is a problem. It's a waste of resources. It's a deadlock. It's a situation where you can have a lot of problems. For example, what if I have access to a resource somebody else is waiting for, and I'm stuck? I will probably affect the performance and ability to terminate their execution of other threads. So this is a very nasty situation I want to avoid, and that's the reason why when I try to join for myself, when a thread tries to join for itself, a runtime exception is raised. Well, let's consider this situation. I want to have this fancy code where I have a join, and the join has a timeout. So I call the join on another thread, of course. How can I know that the other thread terminate because the timeout expired, or because it simply completed its execution? I have no means to know. The join does not provide me the tools to actually understand it. So the EasyLive method comes to help us, and you can invoke this method to understand whether or not a thread is actually alive, it's running. So basically, the method returns true if we call EasyLive on a running thread, returns false otherwise. So that's very important, because it's the only way we have to actually understand the reason why we have been unblocked after a join, in the case the join has a timeout. As a final remark, let me say that I typically see the use of joins with timeouts in the area of distributed system, where you have probably where you acquire several resources, and it's necessary to avoid situation where basically you wait for too much time. So otherwise, it tends to be quite infrequent to see join with timeouts. And when you start implementing multi-threading application in Python, well, I strongly discourage you from applying this technique. So let me say that for the beginning, at least, let's try to do our experimentation with purely blocking join methods. So don't pass in any timeout to the join. Threads can also have a name. A name is just a string. It has no semantics. It means nothing. It means something to you, the programmer. Multiple threads can have the same name, so the name is not a unique identifier. It's just a metadata, if you want. It's just a tag, if you prefer. If you don't set up any name, the initial name is set up by the constructor itself. Threads have also a so-called thread identifier. Well, you can access the thread identifier through the getIdent method. Well, the method returns the thread identifier of the current thread, and it is a non-zero integer. The value has no meaning. It's just a unique identifier. You can use it, for example, if you want to use it in a dictionary of thread-specific data. So maybe you have a dictionary where every thread is associated with some information, and you need an identifier to associate your current thread with its data. So this identifier, the getInt identifier, could be a very useful tool to access this data, to index this data. Python threads are mapped to kernel threads. Well, the thread native ID is a non-negative integer value that can be used to identify a thread system-wide. So the thread identifier is a value that is assigned by the operating system to the thread. That value is unique for a given time. It may be recycled by the operating system after the thread terminates. You can access the thread native ID through the getNativeID method. Let's now consider this simple application example. We have the myThread function that implements the thread logic, and we have a simple main which is in charge of starting a thread, creating a thread, starting a thread, and waits until the thread terminates. The thread is very simple. The thread can simply print thread identifier and thread native identifier. You can access the method through the threading.getIdent or getNativeID method. So something very, very, very simple. Let's see the result of this operation. As usual, we start the application from the terminal, and the thread is created, it's started, and prints thread identifier 140421 blah blah blah, and thread native identifier 29773. That's it. So the thread identifier is an integer number that has no meaning and is associated to the thread, whereas the thread native ID, the TID, is an identifier, an integer identifier that uniquely identifies a thread system-wide by the operating system. Let us note that this identifier is unique but can be recycled by the operating system. So when a thread terminates, the same ID can be associated to a different thread. So if you want to use it in your application, fine, but think about this. It's unique at a given time. Okay? It's time to speak about daemon threads. Well, daemon threads are intended to execute tasks in the background, the type of tasks that are instrumental for the execution of non-daemon threads. Examples of this operation are writing logs on a file in the background, managing garbage collection, and so forth. It's worth noticing that it's not necessary for this type of operation to coordinate the threads that implement your business logic with the daemon threads. So, an important aspect of daemon threads is that you don't need to join them. They terminates basically when the main program terminates. So when we exit the main program, these daemon threads terminate their execution and we don't need to join them. That's the main difference with the threads we are getting used to. In order to have your thread become a daemon, you need to explicitly set this flag. This flag is a boolean indicating whether the thread is a daemon, and in this case the boolean has a true value, false otherwise. Let me stress, you can set this boolean, you can set this flag either on the constructor, because the thread class has an argument, the daemon argument, where you can set whether the thread you're building will be a daemon or otherwise. Or you can rely on the setDaemon method. Let me stress that the method must be called, the setDaemon must be called before the thread is actually started. Otherwise, a runtime error is raised. It makes sense. It's not possible to change runtime the behavior of a thread. So when you start a thread, the system needs to know whether the thread should be treated as a daemon or as an ordinary thread. It makes sense. It's kind of intuitive. There's a difference in the management of the different threads. So before starting, you need to know what to do with the thread. Let me stress that the main thread is not a daemon. Therefore, all the threads that are created by the main have by default the daemon behavior set to false, so they are not daemon. And this is very important. So the message is, if you need to create a daemon, you need to specify that the thread is actually a daemon. Okay? Now let's consider a simple example of a daemon thread. So the idea here is just to show you how you can set up a thread as a daemon thread. We have a simple myThread function that implements the thread logic, and in this case the thread logic is extremely simple. We just simply print hello, I'm a daemon thread. Typical activities here should be, we repeat it, should be log management, garbage collector, or maybe pinging some server to say that the application is still alive and running, or management activities. So activities that are functional to the correct behavior of the overall system. This is the type of activity you want. Let us stress that basically we create the thread as usual, we could have used we could have passed the daemon argument in the thread constructor. Okay, here we set the thread as daemon by using the setDaemon method, and in particular we pass in the true value, meaning that the thread is a daemon. Then only after we set the daemon flag we can start the thread. If we try to change the behavior of the thread at runtime while it's running, we get an exception, okay? So it's very important that we do it in advance. And when does the daemon thread terminate? Well, the daemon thread terminates either when its execution terminates. In this case, after we print a simple string, or when the main thread terminates, when the application terminates. And notice we don't have any join in this simple code. We don't need it because it's a daemon. So it runs as long as the application is running. Why? Because the daemon threads are expected to implement activities that are functional to the correct behavior of the application. That's it. As simple as that. Time for a summary. Basically, we discussed the main method that should be used for the implementation of threads in Python. We had some insight on the threading module and in particular on the thread class.